Welcome to doassignment-ca. Here is the problem. A particle is moving with a velocity of v-naught when s equals 0 and t equals 0. If it is subjected to a deceleration of a equals negative k times v cubed, where k is a constant, determine its velocity and position as functions of time. Now let us work through the solution step by step. We start from the definition that acceleration equals dv over dt. Setting that equal to negative k times v cubed gives us a separable ordinary differential equation. We move all terms involving v to the left side and all terms involving t to the right side, giving v to the negative 3 dv equals negative k dt. We integrate both sides using definite integrals. The left side uses the power rule and gives v to the negative 2 divided by negative 2, evaluated from v0 to v. The right side gives negative k times t. After applying the limits, we obtain negative 1 over 2 v squared plus 1 over 2 v0 squared equals negative kt. Rearranging, we bring the negative 1 over 2 v squared to the right side and isolate it. Multiplying through by 2 gives 1 over v squared equals 1 over v0 squared plus 2 kt. Taking the reciprocal of both sides and then the positive square root, since the particle moves in the positive direction, we obtain the velocity as a function of time. V of t equals v0 divided by the square root of the quantity 1 plus 2 k v0 squared times t. Now we use the fact that velocity equals ds over dt. Substituting our expression for v of t, we separate variables again and set up a definite integral from 0 to t, matching the initial condition that s equals 0 when t equals 0. We evaluate the integral using a u substitution, letting u equal 1 plus 2k v0 squared times t prime. After substituting, integrating the power of u, and evaluating at the limits, we find that position as a function of time equals 1 over k v0 times the quantity square root of 1 plus 2k v0 squared t minus 1. We verify by checking initial conditions, v at 0 equals v0 and s at 0 equals 0, both confirmed. Differentiating the velocity expression with respect to time using the chain rule and simplifying reproduces the original acceleration law, negative k times v cubed, confirming our solution is correct. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.